Welcome to the next episode of groundwater. In this episode, we are dealing with water bearing formations. Various types of water bearing formations. On the basis of storage and accumulation of groundwater, 4 types of rocks are recognized. They are aquifer, aquiclude, aquitard and aquifuge. This classification is mainly based on the water bearing capacity of rock. Coming to the aquifer, an aquifer is a large body of permeable material where groundwater is present in the saturated zone. So, aquifer is a very good water bearing formation. So, any water bearing formations you can call by the term aquifer. And this aquifer is a large body present within the saturated zone. So, saturated zone is a zone where most of the pore spaces are filled with water. A good aquifers are those with high permeability such as poorly cemented sands, gravels and sandstones or highly fractured rock. So, a good aquifer is having high permeability and poorly cemented sands. Gravels are all examples for this. Aquifers can be of mainly 2 types. They are unconfined aquifer and confined aquifer. Aquifers are again classified on the basis of their storage capacity. So, that is unconfined aquifer and confined aquifer. Unconfined aquifers, the most common type of aquifer where the water table is exposed to the earth's atmosphere through the zone of aeration. So, here unconfined aquifer, it is exposed to the zone of aeration. Most of the aquifers depicted so far in the drawings are all of unconfined. Whereas confined aquifer, these are less common, but occur when an aquifer is confined between layers of impermeable strata. That means, a permeable layer is sandwiched between 2 impermeable strata. A special kind of confined aquifer is an Artesian aquifer. Normal wells are considered as unconfined aquifers, and this Artesian type well or Artesian springs are considered as confined aquifers. So, water flowing in this confined aquifer is under normal atmospheric conditions. That means, it is due to the pressure difference the water overflows, whereas in the unconfined aquifer, that is in the normal well, the water will not overflow. So, that is the difference between a confined aquifer and an unconfined. In a confined aquifer, a permeable layer is sandwiched between 2 impermeable strata. So, the water automatically rises up in this type of confined aquifer. So, here the recharge area is gaining water. As soon as the water gets recharged, the confined aquifer works or it overflows. So, this free type water bearing aquifer is known as confined aquifer. Then comes aquiclude. If the material has porosity, but no permeability, it is called an aquiclude. The material has porosity, that means it has enough pore spaces, but no permeability. Permeability in the sense it is not allowing the water to pass through it. So, that type of water bearing formations you can call it as aquicludes. So, the best example is clay. Aquiclude is a solid impermeable area underlying or overlying an aquifer. So, in this layer it has porosity, but it is not allowing the water to pass through it. That means, permeability is less. If the impermeable area overlies the aquifer, pressure could cause it to become a confined aquifer. So, this is the depiction for the aquiclude. So, aquiclude is considered as the dark blue color and it is between 2 unconfined, and here water, it is a material has porosity, but it has no permeability. That means, it will not allow the water to pass, but it has porosity. So, this type of water bearing formation is known as aquiclude, and the best example for this type of aquiclude is clay. Then comes Aquitard. If an aquiclude has limited permeability, it is known as Aquitard. So, if an aquiclude which has limited permeability, it is known as Aquitard. So, that means clay is a very good example for the aquiclude. The clay with restricted amount of silt is considered as Aquitard. So, clay size particles along with some silt size particles are also present. So, silt size particles automatically have porosity more than this clay size particle. So, clay with restricted amount of silt is considered to be a very good example for Aquitard. So, Aquitard is a zone when the earth that restricts the flow of groundwater from one aquifer to another. A completely impermeable aquitard is called an aquiclude or aquifuge. Aquitards comprise layers of either clay or non-porous rock with low hydraulic conductivity. So, this low hydraulic conductivity is very good for this type of water bearing formations. Next is aquifuge. These are the rock impervious to water, that is example is non-fissured massive crystalline rock. So, massive crystalline rock here if it is non-fissured, it will not allow the water to pass through it. So, it is an example for aquifuge. It is a geological formation which is neither porous nor permeable. So, aquifuge is a water bearing formation in which it is neither porous nor permeable. Neither porous in the sense there is no pore spaces present within the water bearing formations, and it is also not permeable, and non-porous means the pore spaces are not there and the pore spaces are also not interconnected. So, this type of neither porous nor permeable type water bearing formations are known as aquifuge. So, these are not having any interconnected openings and hence it cannot transmit water. So, this type of water bearing formation cannot hold or transmit water. So, massive compact rock without any fracture is an aquifuge. So, very good example for an aquifuge is a compact rock without any fractures. If there are some fractures, it will allow the water to pass through it. So, in this case, in the case of this type of aquifuge, there are no fractures present. So, without this fractures, the water cannot pass through the water cannot pass through the rocks. Next is artesian well. So, artesian well is a particular well in which water level in an artesian aquifer sometimes rises above the surface to cause the well to flow. This type of well in which water is forced upward under natural pressure is called an artesian well. The artesian well is a particular type of well in which water automatically rises up without any external thing, but that means the water is forced upward under natural pressure, and this type of well you can call it as artesian well. To be an artesian well, the water in the aquifer must be under enough pressure to force it up and the well to a level that is higher than the top of the aquifer. So, to be an artesian well, water in the aquifer must be under enough pressure. So, this pressure must force the water to the top surface of the well, and because of this the water is overflowing in this type of well. So, artesian water had no any special chemical or medicinal qualities. Only thing is the water is just rising up under enough pressure to force it up. So, because of this property, it is having artesian condition. So, in this figure here, this is a permeable thing. This permeable layer is always getting enough water, that is the recharge. So, in this aquifer always recharge is taking place, and this aquifer is sandwiched between two impermeable layers, and you can see that the well dug in this position, that is artesian well, almost the water is automatically flowing upwards, that is because of the pressure this water automatically rises up, and in this condition it is known as artesian well. So, in this picture a permeable rock. So, that is an aquifer sandwiched between two impermeable things. So, here there is a fracture present. So, fracture due to that fault, water is automatically rising up from the fault region. So, you can see a black colored fault in the particular rock terrain, and due to faulting the layers are displaced. So, that you can clearly see the demarcation in that layers are clearly demarcated. That means a fault is present, and due to faulting water is coming through the gap, and here also the water is pushing automatically up. So, that condition is known as artesian condition. The main thing is it is getting enough water to recharge. The permeable layer or the aquifer is completely getting enough water to recharge. So, as soon as the water fills within this aquifer, it starts to be overflow as artesian wells. So, this is another picture in which that blue color represents the permeable layer. So, that permeable layer is sandwiched between two impermeable layers, and the water automatically rises up. So, this is a saturation level. So, artesian well continues to overflow in this particular position. So, artesian system occurs where groundwater under pressure rises above the surface of the aquifer to the artesian pressure surface. An artesian well will flow without pumping. So, there is no need for extra pumping, automatically it will flow if the well head lies below the pressure surface. So, an artesian well will flow without pumping if the well head lies below the pressure surface. So, there are some conditions necessary for an artesian system. It includes water is contained in an inclined aquifer whose upward end receives water. So, the upward end receives water means the maximum recharge is possible in this area. Aquicludes are present above and below the aquifer to trap the water. So, in between above and below there is suitable aquicludes. So, this aquicludes will trap the water in between the aquifer, and there is sufficient recharge to keep the aquifer filled. So, always the aquifer must be recharged. So, there is enough water to recharge the aquifer, then only there will be enough water in the artesian type well. Next is springs. Springs represent natural discharge of groundwater occurring where the water table intersects the earth surface. There are, you can see small springs arising in the rainy seasons. So, these springs are nothing but natural discharge of groundwater occurring where the water table intersects the earth surface. So, wherever the water table is intersecting the earth surface, that point is discharged as springs. So, most commonly occur along valley and along the walls of the valley where streams have eroded below the level of the water table. So, these type of springs are commonly seen in the rainy seasons. Hilly areas and in the valley regions you can see small traps of water. So, this type of small discharge or seepage of water you can call it as springs. So, in this picture water table is demarcated as the blue color. Once the water table is exposed the surface, that exposure point is designated as a stream. So, it's a flow of water along this position, you can call it as a stream. Hot springs. Hot springs are springs that bring water to the surface, that is at least 6.5 degree Celsius higher than the mean air temperature. So, normal springs it comprises of water with ordinary temperature. If this type of spring which having temperature at least 6.5 degree, it is considered as hot spring. So, if there is an hot spring found in a particular region, we can infer that that particular region is somewhere surrounded by a magmatic action. So, due to the magmatic emission, the water table or the water mixes with the normal water, and this type of hot springs or lighter temperature water is coming through the springs. Geysers. Geysers are hot springs which periodically emit columns of water and steam with great force. So, this is a type of hot spring in which it periodically emits columns of water and steam with great pressure. So, it is a periodical emission of water and steam. So, the temperature is higher than hot springs. They occur where groundwater percolates into the underground chamber that exists in hot rock. So, these type of geysers occur where the groundwater percolates into the underground chambers that exist in the hot rock. So, if the groundwater percolates or come near to the magma chamber, automatically magma chamber is having high temperature. So, once the groundwater mixes with the magma or surrounding rock, the temperature is increased. So, because of the impact of this magma chamber, what happens is it emits groundwater. This type of hot springs or geysers emit periodically columns of water and steam. So, the steam and water, hot water is mainly produced by the magmatic action. So, water eventually holds under great pressure and forces its way to the surface. Cooler groundwater seeps back in and the cycle is repeated. So, once the water starts coming through this type of hot spring, slowly more and more groundwater mixes with the hot water and this cycle goes on continuously. Now, we can look back once more into the types of water bearing formations. Mainly there are 4 types of water bearing formations. They are aquifer, aquiclude, aquitard and aquifuge. An aquifer is a very large body of permeable material where groundwater is present in the saturated zone. An aquifer can be of 2 types, unconfined and confined aquifer. Unconfined aquifer are the most common type of aquifer. Here the water table is exposed to the earth's atmosphere through the zone of aeration. Whereas, in the case of confined aquifer, these are less common and occurs when an aquifer is confined between layers of impermeable strata. A very special type of confined aquifer is an Artesian wells or Artesian springs. An aquiclude, it is a material has porosity but no permeability. This type of water bearing formations are known as aquiclude, and the best example for an aquiclude is a clay. Next is Aquitard. If an aquiclude has limited permeability, it is known as an Aquitard. So, the best example is clay with a restricted amount of silt. It is considered as an Aquitard. So, the clay has already very good Aquitard, but if it is having a restricted amount of silt, it acts like a very good Aquitard. Next is aquifuge. These are rocks impervious to water. That means they are the geological formation which is neither porous nor permeable. It is having no porosity and no permeability. So, it cannot transmit water through this. So, that is an impervious layer. This type of water bearing formation is known as aquifuge. So, the best example is massive compact rock without any fracture. So, if there is no fracture, there is no chance of water to transmit through this rock. Artesian wells. So, this is a special type of well in which water level in the Artesian aquifer sometimes rises above the surface to cause the well to overflow. This condition is known as Artesian well. Some conditions necessary for an Artesian system is water is contained in an inclined aquifer whose upward end receives water, and aquicludes are present above and below the aquifer to trap the water. There is sufficient recharge to keep the aquifer filled. Then coming to the springs. Springs represent natural discharge of groundwater occurring where the water table intersects the earth's surface. So, when the water table is freely exposed to the earth's surface, it is demarcated as springs. Hot springs are the springs which transmit water with at least 6.5 degree higher than the normal temperature. Most of the hot springs are mainly associated with igneous activity, and geysers are a very special type of hot springs which periodically emit columns of water and steam with great force. This is also accompanied with volcanic action. By this we came to the end of this session. I hope you understood all the topics discussed in this particular session. Our next session is about the geological work of groundwater. Till then, bye.